Sein. Hören Sie einen geraden Ton ausprobieren. Du könntest theoretisch, wenn du den Link kennen würdest, den ich dir noch nicht geschickt habe, ich schicke dir ihn jetzt sofort, feststellen, ob der Livestream wirklich mit gutem Sound versehen ist. Ich werde den Livestream einfach starten. Es kriegt eh keiner mit, weil er nicht kommuniziert ist. Das macht es alles einfacher. Der Livestream ist gestartet. Ja, ja, genau. Ich schicke dir ihn dir gleich bei Slack. Dann ist es besser. Ich werde einfach weiterreden. Was werde ich machen? Ich werde jetzt gleich diesen Livestream an den Tom schicken. Ich habe ihn mir irgendwo gespeichert, ich glaube in meinem eigenen Kanal. Hier ist er schon. Ich werde jetzt diesen YouTube-Stream kopieren und dem Tom Ullner auf sein Slack schicken. Copy Link, Tom Ullner finden. Das geht mit Steuerung K bei Slack. Ich suche nach Tom Ullner und der hat Tortillas gekauft, war bei Aldi. Ich schicke ihm den Link. Den Link habe ich dem Tom jetzt geschickt. Tom kann jetzt checken, ob der Livestream in toller Qualität bei ihm ankommt. Der Helge kann ihn gern dafür besuchen gehen. Vielleicht glaubt man mir das, dass es gut funktioniert. Ich werde so lange schon mal vielleicht auf die Kameras umschalten. Das hat er sogar schon getan. Man sieht mich laufen. Wahrscheinlich ist das ein bisschen langsam und man hört mich auf jeden Fall versetzt. Naja, Sie sehen hier die internationale Raumstation, wie sie gerade an dem Planeten Erde vorbeizieht und einen Wirbelsturm fotografiert. Das ist das Auge des Sturms gewesen, eine Sojus-Kapsel und die Observationsstation. Jeder Astronaut hat eine Stunde Zeit am Tag, in dieser Observationsstation die Erde zu betrachten. Wir gucken gerade NASA-Television über alles Mögliche. Meine Güte, hier fliegen aber auch die Schriftarten hin und her. Da kann man sich kaum konzentrieren.
Aufregend.
Funktioniert auch alles noch aufregend. Gibt es eine Frage aus dem Publikum? Wir hören gerne Fragen. Sie müssen Fragen stellen.
Warum ist denn das hier in Deutsch?
Warum ist das in Deutsch? Weil das nur ein Soundcheck ist. Sie können diesen Soundcheck.
Hallo und herzlich willkommen zu Coding Berlin. Diese Woche mit dem Blockchain Special bei Turbine Kreuzberg. Wir testen mal, ob Stefan mich hören kann, ob der Sound im Stream ankommt. Test, Test, 1, 2, 3. Hallo Stefan. Ich kann mich sehr gut hören. Die Gäste können mich auch alle sehr gut verstehen. Test, Test.
Und wir sehen uns morgen. Bis dann. Ja, ja.
So I think you could connect your computer here with the HDMI or whatever you need.
No, that's all I need actually. Last question, I know I'm being a pain in the ass. Do you have an extra keyboard that I can plug in USB? I have one that's just
working with Bluetooth.
Bluetooth would, yeah.
Yeah, then I'll bring you mine. Okay.
Okay. All set.
Very nice.
Everything's working perfectly.
Everything you do is already visible on YouTube, but since nobody has the link, nobody can see it.
Perfect.
Anyway, the streaming is far too slow anyway, because this machine has far too much to do. I don't know what's happening. But maybe the audio is good. It's good.
So there will be a live stream or not?
I'm going to, the stream won't be communicated, but I'm recording. So if the recording is good, let's see how the quality is going to be today. I think we have to use a new Mac. If it's good, you can absolutely have it if you want.
I started already up. It's my first sticker on the.
Whoa, yeah, you. Thank you.
I've honestly fallen in love with the city. Like it's my first time in.
Berlin.
It's weird. Like no one seems to give a fuck what people think, which is nice.
Absolutely.
Different from Miami. Very different from Miami. Different from Miami.
Miami.
And no, it's you have the culture and the political history. I like it a lot.
It's very liberal, but it's also in Germany. It depends on which city you are. If you are in Frankfurt, it's different.
I've been to Munich, and it's
Munich is also different.
like a few years ago, but it's very different. It's not as international.
And Berlin is also a little bit depending on where you are in Berlin. If you're in this area, so on the weekend we have been in Kreuzberg. This is, as I said, if you look like a bum, you fit in perfectly.
Yeah.
This is how things are working here. But if you move out a little bit, like to Spandau, where I'm coming from, so people are actually also wearing ties.
Yeah.
If you want, there are some people on the balcony who
Sure. I was actually going to think about it for a second. Go outside.
I don't think you have a minute.
Yes, indeed.
So I can connect my laptop in.
Exactly.
So I've just got like mainly a presentation, but I'm going to do like a small tech demo. So hopefully it
Stefan
doesn't
would love it.
actually.
Yeah.
Oh, fun, my demo.
Yeah.
He'd love
Hopefully,
it.
let's hope
Perfect.
it doesn't break. So yeah, I can like connect in, and that would be
Sure.
awesome.
Yeah.
Cool.
So, do you need anything else in HMI?
I think I will need to use that,
Awesome.
but I guess that will be fine. I'll just test it out now quickly, and then make sure I've closed down all of my chat apps.
Okay.
Ahead of the talk.
and stop the notifications.
Yes, exactly. So
Are
that
you
works.
coming home?
Yeah.
Wow. So, you see there, if you need like to charge your computer or anything, right?
Ah, nice, thank you.
Okay. You want to do it on your own, or shall I stay?
It's up to you. Like, I don't want to keep you because I know you're kind of
Yeah,
doing
that's
the event
fine.
stuff.
Okay. I just stop by and do it.
Thank you.
Awesome.
Cheers.
Hey,
Yeah.
So, Rachel.
Hi, nice to meet you. So I didn't catch you at.
I'm sorry, I'm meeting so many people there.
No, I know, it's like super hectic. It's like.
Raketenstartrampe. Read that rampe, R-A-M-P-E.
Oh yeah, R-A-M-P-E.
E. There you go, Start. It's the launch pad, the rocket launch pad.
Nice, nice. How's it going?
Oh, pretty well, yeah.
Did you enjoy the Blockchain Week so far?
Yeah, so yeah, I've been to DebCon and to all 3 days, like Wednesday, Thursday, Friday workshops. Then I went home, had 2 hours of sleep.
Yeah.
Then I went off to the hackathon. And well,
How did you find the hackathon?
Great.
Yeah,
I've been to so many hackathons already, but this one was one of the best organized I've ever seen.
Yeah, yeah.
And no problem was I was hacking through 2 nights, so I only get for 2 nights maybe 3 hours of sleep. So
It's
as many
kind
other
of
people.
intense, isn't it?
Was
It's
really
kind of intense. What did you build?
We built the door. The door with the the stroke D.
Yeah.
Oh yeah, I
It's
saw
so
your
nice.
stuff on the.
Have you seen it? Okay, it's quite funny because it's an admission system for events. Like if you do a meetup, And you want to make sure that the guys coming into a meetup are the ones that are registered.
Yeah.
We have to solve two questions. The first question is, does this public address have a ticket? So like one in the smart contract.
Yeah.
The other question is this really this guy who's holding the public address? And we have an off-chain, so we're just signing a secret with a private key, so we can verify at the door that he's really the guy he says he is. Well, it just worked out. Everything worked in the end.
Nice. It's good to build something
You
working.
take the stuff, I bring in all the people. Do you think it's working?
Yes, it is
Okay.
working. Do you know, I'm the second speaker, right?
Yeah.
Yeah, cool. I might grab a bottle of water as well,
Yeah,
actually.
sure. Just take your time.
Cool.
I'll do an intro, which is taking 10 minutes anyway.
Okay, nice.
At least I hope so.
So it's Algorand, then me.
Algorand,
and then
Lisk,
Hybrix.
and then Helix AI. Hybrix?
No,
Helix,
Helix.
not Hybrix, right?
Okay, cool.
Hybrix.
Sorry.
Oh, I forgot Hybrix. They told me that they had some swag, but they didn't bring it. And it's a long start. So I'll bring up the people.
Cool, I'm just going to go
You
back
grab
up to
a
grab
water.
some water.
Yeah, just a lot. We got lots of space in the front row. That's one of the best places, right? It's cooler.
Yeah,
Yeah.
exactly. Yeah, pretty much.
So after I did the intro, I will try to get some climate thing like AC or so. I think we still have some. Okay. Sir, do you see if someone's still out there, or have you been the last? Oh, and wait them in. It's taking too long. We have to stop. Okay. So, there we go. Usually the no-show rate is around 50%. I'm quite amazed that if 40 people sign in, 40 people arrive. This is what we have not really been prepared for, but thank you for coming anyway. Before I start, usually I forget this. This is why I'm asking you to take a picture, at least to wave now, so you look very alive and smile and do something and grin, right? And cheer, and this is so silent here. Coding Berlin, right, get out of here. Awful. So, we are Coding Berlin. Who of you has been here before at Coding Berlin, I mean? The funny thing is, I always like to call this a community. It doesn't work if no one's returning. Never mind, good to have you here. Maybe you're the new Coding Berlin community. This is our Blockchain Week Special Meetup. And I'm very proud that we have three quite amazing speakers from three even more amazing companies with us, Algorand, Lisk, and Helix. Thank you so much for being here, for still being here, I assume. I think you also went to the Blockchain Week, this is why you're still here. And for being here to Winnie Kreuzberg to talk at Coding Berlin. Thank you to Winnie Kreuzberg for the rest. So there's obviously some company paying for everything that you're drinking and eating, and this is the company that also pays me. But as I said in the beginning, Coding Berlin tries to be, we are a community and we try to be an open community. So it is not mandatory that Winnie Kreuzberg is doing it every time. If you're working for a company who wants to host meetups, please tell me or Tom, who just left the room, that we can maybe host a meetup next time in your amazing space, if it's even more amazing than ours. So there will be, it's very dark there, barbecue. If we do the talks very quickly, it might be even still light outside, but take your time because we want to hear all of your story. And then one word, Coding Berlin is not alone. We also have a Coding Earth Association that we are working for, that we have founded. There's Coding Stuttgart, Coding Leipzig, Coding Portugal, Lisbon, Porto, Coimbra, and Faro. And what these meetups try to do, we want to be a friendly and open hub for developers, and we have one rule only, and this is the major rule: it must be code-centric. Code-centric. Everything you do should deal with code. No marketing, no recruiting, no, you know the game. Every meetup should come with a different dev-related topic, and everyone's invited, talk, host, or suggest. You can join us in Slack. We have a very nice Slack channel. It's very good if you, I'm sorry, people, because I can hear myself if you talk, right? Thank you. It's very, very hard to speak if I hear you people talking because of noise. And so if you want to join us on Slack, you can even chat with us, and you can talk to us on Twitter. We even have a Coding Berlin handle on Twitter, so if you want to follow us, you might stay up to date with the latest news. We have 3 talks today by Sam, by Rachel, and by Dimitri. Thanks for being here. And then I have some announcements, because some people are approaching me and tell me, Stefan, could you please tell all your people that we are doing this? So let's start with something Java related. On September the 3rd at the WeWork Potsdamer Platz, 6 p.m., IBM is doing a Kubernetes cloud native Java workshop, which is, as far as I know, free, and they will talk about, or they will help you with, the microprofile Kubernetes, containers, REST APIs, traffic management, and resiliency. I'll send it around, Andreas, just for you. Okay. Any other Java developers around? Java? Yeah, 1, 2, okay. Ooh, well, I'm doing PHP. So, next one. The Femtech boom. Female health in the spotlight. There's a meetup happening tomorrow. We are going to have Tina Dingel, the CEO of Clue. And maybe you guess what this is all about, right? Busmit networking. Then we have, who of you has joined the F Berlin 2 hackathon last weekend? Some of you. Not too many, okay. Yeah, oh, you, okay. If you want to go to the next hackathon, there's the Fusion 2019 happening on October 19th and 20th in the Factory Berlin. You can still sign up on DevPost, and the choice of technology is a little bit broader than on last weekend. So you can hack with IOTA, the Ocean Protocol, Ethereum, Chainlink, Sovereign, and there are 3 or 4 other technologies. And I think it looks like quite an amazing event. And it's happening at Factory, so if you like the Bällebad, you can go there again. One more thing. They approached me today. Of course, they've seen, oh, so many people coming. Let's announce them. Are there any JavaScript developers around? Very good. If you want to go to Antwerp, which is a very nice little town in Belgium, October 23rd until 25th, you get 100 euros discount. I think regular price is 400 or 500 euros, I don't know. So if you want to save 100 euros on them, JS Developers Berlin, and then you save 100 euros on the ticket. Who of you is doing React? Okay, the React Day Berlin is happening on December the 6th. They are still looking for speakers. The call for papers is open until August the 31st. If you want to speak in front of a large audience, go there, because the React community in Berlin is quite amazing, and you get 50%. So if you apply as a speaker and you are taken, you of course go there for free. More chairs. And if you don't want to speak, you can go there with Coding Berlin, 50% off. And we even have a raffle, but I have to come up with the rules so we can give away 1 ticket. I'll try to figure out the rules. That was it from my side so far. If you need restrooms, the restrooms are in the middle of the hallway. The way we are doing this here, at least we try so. We try to do first the 3 talks, and then we're going to do the barbecue. If you just fall over because you're too tired, we have to have some kind of break, right? So I'm not exactly sure how long the talks will last, but we're going to have a talk, a 5-10 minutes break, another talk, a 5-10 minutes break, another talk, and then the barbecue. Okay? Understood? Everyone's still with me? Yeah. Okay, good. Then let's get that thing started with Sam. Thank you. Do you want to wear the microphone? So then I'm definitely recording. So if you want, I can help you with that. If you want.
Yeah.
That would be good.
Do you have that one?
Yeah, it's over there.
Yeah. Do you want me to put it on?
I can. You have to.
It's a headpiece.
Oh, this way. Then. And I will just put it behind you.
So I hope
Trying to say something. It should be louder.
test.
You should switch on. It's on, no? Say something.
Test.
Yes.
Okay.
Okay, let's go.
Thank you everyone for coming, first off. So it's my first time in Berlin. I'm based in Miami, Florida. The Algorand team is based in Boston. So first of all, I understand that I'm overdressed. I'm actually out of clothes because I didn't realize that people in here tend to dress down. So I'm sorry about that. But anyway, so my name is Sam. I'm with Developer Relations at Algorand. We're a pure proof-of-stake blockchain. I'll go into what that means in a second. So this is Amy. She's our community ambassador here in Berlin. She's based here, the beautiful Amy. To the right, we have Russ, another tech evangelist, me, Silvio, our founder, and Liz, she's one of our product managers. We were all here for this last week. I've been here for 10 days now, both for ETH Berlin, for DAppCon, and then for the hackathon as well. That doesn't matter. Okay, so there's a little survey. So just full disclosure, we're trying to figure out what type of developers will be attracted to our platform, right? We're trying to figure out what our market fit is, culturally where we are in this spectrum. I have 3 different YubiKeys, keys, so your chances are pretty good. If you just, it's literally just your email, your name, and then I'll do a raffle at the end, and I'll give out 3 YubiKeys. keys. So these are our main resources. The PowerPoint I can post. I'll give it to Stefan. But these are our dev docs. Our SDKs are on GitHub. So we have SDKs in Java, Go, JavaScript, and Python. And you can find all those here, and also instructions on how to get started as well in the dev docs. These were just some of the prizes. I used this slide before. These were some of the prizes that we gave out at the hackathon. Raspberry Pis. I love hardware prizes. I think they're great for hackathons. Everyone gives cash, which is nice, but I think something hands-on would be great. We also gave away Go antennas. These were for mesh networks. So next time I come to Berlin, I'll bring more with me. So, okay, so yeah, this is the blockchain promise, right? Things are tamper-proof, transparent, and trust is weird. It's supposed to be a trusted, trustless system in a way. Are all of you familiar with blockchain? Or okay, who's like it's the first time you're into blockchain? One? Okay, I'm not gonna preach, but no, I'll just go a little bit into it. So full disclosure, so I started in this space with Ethereum because it's just the lowest barrier to entry. If you're a JavaScript developer, you're fine in Solidity. I moved over to Bitcoin, focused a lot of my time on Lightning Network, and also culturally, I'm also more of a Bitcoiner. The reason why I wanted to discuss trust in all these different aspects is because there's a spectrum of decentralization. And there's also, every single network seems to fit along in a different category. And one of my favorite things to do is look at the cultural dynamics of it. So, for instance, I don't really seem to trust anyone. Like, if you tell me something, I'll listen and I'll nod. But I don't really believe you until you can actually prove to me whatever you're saying, right? For the most part. So that puts me more in the Bitcoiner camp, where it's that I want to self-validate, right? Something interesting in that regard is that, Bitcoin itself, I think, delivers on its promise of being an environment of censorship-resistant transactions. It accomplishes that beautifully. It's also a free market of energy consumption. And that's also debatable, more of a consensus topic based on where you stand on renewables and energy. But with respect to competing over, some sort of free market of being a validator, of being someone that can actually maintain a network, Bitcoin seems to be the one that is the most free in that respect. And then you move over to the Ethereum side, and Ethereum seems to be kind of the platform where you can accomplish your dreams and whatever you want in any kind of way or any kind of capacity. And it seems to be more of the prototyping experimental network, which I respect a lot because you need that as well. You kind of need to have those two balances. So finding Algorand's market fit, I think, mainnet's been launched for 2 months now. So it's still a new network. And we really have to figure out who's going to be attracted to us in the first place. Is it going to be more legacy financial institutions? Is it going to be more gaming? All that's kind of left to be figured out. One of the, and I'll go into this in a second, but one of the main drawbacks is that we actually don't have smart contracts as of yet, right? So we plan to have smart contracts in the first year. But I believe for network maintenance and for scalability reasons, Silvio, who's our founder, decided to limit that as much as possible. So our SDKs allow you to basically have smart contract functionality without a scripting language and a virtual machine on the network. So the way it works is we have a transaction object. Inside of that transaction object, there's a field called a note field. And in that, you can write a kilobyte of data. So everything you can run off chain and then commit that to the network as part of the whole transaction object. So functionally, that's more or less how that works. So yeah, all this. So what is Algorand? Well, actually, let me go here. So we're a pure proof of stake blockchain. If you, so Silvio Macaulay was one of the authors of zero knowledge proofs. If you're familiar with ZK snarks, it's a privacy feature in Zcash, also in ZCL, and it's arguably the most robust privacy feature for a blockchain network. Now, what Silvio did then is basically create a derivative of that called VRFs, verifiable random functions, and that's effectively what defines the entire consensus and what makes block validation or block creation and block validation so fast. So our technical advancements basically is, well, VRFs, so it's very fast Byzantine agreement defined by VRFs, and player replaceability is basically the freedom for different actors to take part in consensus. If you're a token holder, you're automatically taking part in consensus. You're automatically voting on every single block that actually happens. You don't have to run a node necessarily to take part in the consensus model, but having a token will automatically allow you to vote on every subsequent block that actually goes through the whole blockchain. So these are VRFs. Now, just like zero knowledge proofs, I don't really claim to understand the underlying mathematics of it. If you do, come and talk to me. I'll buy you a couple beers. But it's a complex model that's essentially a cryptographic lottery. Actually, I think I have another slide. So, in a very high level approach, the way it works is that you run your own lottery internally. So, if you're a token holder, every token runs its own lottery. You select yourself. And everyone selects themselves because in that way, no one actually knows who the block proposer will be. So it's very hard to actually attack. It's very hard to conduct a malicious event. Once that token is chosen, then a quorum of around 1,000 people, give or take, it might be less, it might be more, is then chosen to vote on that person. So theoretically, it's hackable. Practically, though, mathematically, it's very, very improbable. We have the Algorand Foundation. To be clear, I'm not going to go into token dynamics because that's not my specialty. I also don't have an interest in really how that works. But just to be clear, the way it works is we have the Algorand Foundation, which did the token offering and runs the monetary policy. And then we have Algorand Inc., which is who I'm a part of, who's contracted out by the Algorand Foundation. So if you want more information, it's algorand.foundation, and dissect that as much as you want. So testnet is fantastic. Our testnet's been launched, or it's been live for a little over a year now. Obviously, do all your development on testnet first. So our node distribution is quite decentralized. And then we've got really great API and command line tools. Go or Go Algorand is our CLI tool, and you have all these different tools that allow you to interface with the blockchain using command lines. So Clerk, for instance, is one of the most popular. Allows you to send transactions, create multi-sig, and also do raw send as well. So our SDKs and Swagger. This is on swagger.hub, and sample code is generated for your language of choice. Sorry, I'm just trying to move through this a little bit quicker. So we have AlgoD and KMD. AlgoD is our consensus process. You can also do key management on AlgoD as well. And then we also have KMD. KMD is really meant for air-gapped applications if you want to run that offline. But like I said, Go, JavaScript, Java, and Python are what the SDKs are written in. So part of this as well, and to be very frank, my job is to figure out, again, who would want to develop on our platform, and I was discussing this earlier. We can go after Ethereum developers, but I think culturally there seems to be kind of a gap. I mean, just marketing-wise, we seem to be very different than Ethereum. And again, given that we don't have smart contract scripting capabilities right now, I also don't know how many Ethereum developers would be attracted to our platform as of now. Even though you can accomplish the same things, it's just not as straightforward as it would be using Solidity. So potentially, our market may be non-blockchain developers, but I think that would be hard selling the whole promise of blockchain and again, this anarcho-capitalistic future that we all tend to believe in to people who have no interest. So that's kind of where we're at with respect to the market. So we have some great coming features. Vault will allow you to basically store the blockchain with very little overhead. It's supposed to, if you're familiar with Bitcoin, potentially just validate using something like block headers in a way. The other thing that I want to talk about was atomic swaps. So they're actually atomic squared swaps, but these are cross-chain and multi-asset swaps in a single transaction. So you wouldn't have to go through the sort of piecemeal, like I'll show you a little bit, then you show me a little bit, and we'll work our way. In atomic swaps, this should happen within one single transaction using a derivative of Silvio's technology. So if you want to be an ambassador, it's also, you can talk to Amy, she's here. So I'm just going to jump straight into the demo. I know we're short on time and I don't want to keep you guys any longer. But what I basically built was a, in full disclosure, I'm a software engineer, I'm not a hardware engineer. So this is very easy to do. But I used a Raspberry Pi, what is it, B? Raspberry Pi 3B Plus. To build what would be an IoT device on Algorand. Now you're also able to run a node on a Raspi. This has 1 GB of RAM. Your SD card can be, I think, as big as you'd like. I've run as large as a 32 gig micro SD card, and everything seems to function perfectly fine. In addition to the Raspberry Pi, I also put an RFID reader. And really what I'm just trying to showcase is how quick our transactions can actually function. So let's see, hopefully this works. This wasn't working about 20 minutes before I started my presentation, so hopefully it works now. And also our testnet's actually under maintenance, so I'm gonna demo what it can do, and you're gonna see it work, but it's not gonna function the way I actually hope to be able to show everyone. So Raspberry Pi, does everyone know what a Raspberry Pi is? Yeah, who doesn't know what a Raspberry Pi is? Really? Sorry? No, it's not the 4. No, I know. But what runs on the 3 doesn't run on the 4 apparently, so I didn't want to risk it. Okay, so let me jump into terminal. And then I will show you. So all this is on GitHub as well. I'm going to clean up the README a bit, but it takes a while. Okay. Relations. Okay, great. Now, I invite you all to take a look at the documentation. If you're a developer, I'd love feedback, honestly. So this is all getting started. How to run a node on Mac, on Ubuntu, Docker, other Linux distros. For reference, this is what I used for the Raspberry Pi. It's really simple. We go over the node overview, different node types, switching networks. So by default, uh-oh. Did I, or did you? I did? We didn't expect to have Raspberry Pis in it. No. I think I killed, okay, there we go. So by default it's set to mainnet, but you can easily switch that to testnet, or you can run your own private instance. And then I just want to show you the SDKs as well. So here's using the SDKs and the REST API. So all of the REST endpoints are exposed. So if you prefer to make API calls, you can do that. It's very simple. And then, yeah, so this is Go. So let me just go to Python. So this is the one that I used. So I code him.
API you're talking about on the node itself?
I'm sorry?
You're talking about an API on the node itself, or is this an Algorand?
On your own node, or you can run a remote instance as well. Yeah, either way. Running your own node's like super simple, and it's very low overhead. But this is the Python SDK. Documentation here is, I'd love feedback on this as well, but that's all available. So let me just run through what I have here. So if you go to github.com/algorand devrel, developer relations, I have this little README here on RFID setup in Raspberry Pi. So this is a RC522 RFID reader. The way it works is a Raspberry Pi has what are called GPIO pins, so general purpose input-output pins, which means that you could really do anything you want with it, or without having to like do any like soldering, or well, you do have to solder for this example, so never mind. This is my first time soldering, so remember, I'm not a hardware engineer. I'd loved it, so I just had this chip and I had to solder in the header pins. You can get a really cheap soldering kit for like $16 if you really want to do this. It was honestly a lot simpler than I thought it would be. But okay, let me just jump into the code so I can show you how this works. So first thing, you want to run raspi config because you have to have your SPI interface enabled. So let's just do that. All right. Oh, shit. Uh-oh. No, that's not what I wanted to do. Damn it. Okay. There we go. So you run sudo raspi config, interfacing options, and then all you have to do is make sure that SPI is enabled. So in my case, it already is. All these, I mean, I did all this, so this is for demonstration purposes. SPI interface is enabled. Okay, and then you go to finish. Now, once that's done, you need to reboot the Pi. I'm not going to reboot the Pi now because just for the sake of time. To make sure that SPI has been enabled, you can run this command, and you should see this BCM2835. If that does show, then it's fine, it's enabled. If it doesn't show, then you would just run this command, nano into this, and then you just have to change a couple parameters, but not a big deal. And again, so sudo apt get update, upgrade, not going to run those just for the sake of time. Then you would install Python and pip. You would install SPI dev, allow you to interface easier. And then MFRC522 is the library that will allow you to interface with the RFID reader. So the diagram here is how you would actually connect the RFID reader to the Raspberry Pi. RFID reader here has its power source, rest, ground, all these different. I actually don't know what these even mean. That's why I'm being very transparent. MISO mostly doesn't matter. And then you connect those to the corresponding pins on the Raspberry Pi. These come from different tutorials. I had to patch them together to do what I wanted to do. And then then you can read from the Pi and write to the Pi. So I just want to show you what I built. So let's see. Let's jump into. You should be able to. Shift maybe. There we go. Is that good? Too big? Sorry. Okay. Let's go into RFID project. And it's test read. All right, so Python 3, test read. Okay. So hold a tag near. I have the tags here. I'll show you the code afterwards. But what this does is I have an account that's hard coded, and it's going to read to me what balance is in my account, what my pending rewards are, and what my total rewards have been. So I think 651 gives me the account. Let's see. Okay, so that's my account. My pending rewards is that much. This is the amount that's currently in that account, and then it also comes with tags as well. Let's see. And my total rewards. Okay, perfect. Now, like I said, test sense under maintenance, so the next part of this, I would do this. I would jump into here, grab my account, copy this. This is my account address. Also, Algorand has accounts and wallets, so that's all in the dev docs. It explains better how that works. Paste that. So just like Ethereum, like they have a faucet. This is our Algorand dispenser. I know it's not pretty, but remember, we're just 2 months old. Dispense. And is the internet down again? Let's try it again. Let's see. Okay. Nice. Now we'll. I don't. Sometimes I'm not sure. Oh, did I get all the buses? Okay. Oh, transaction already in pool. Oh, you know why? Because I did this just before. Okay, so I did this just before. Our testnet isn't like we're running maintenance on it, so it's not going to actually show. But what would happen is that once I dispense each amount, then I could actually rerun this, and I would get different results. But again, in this case, I'm not going to get different results. It'll give me the same thing. So the objective was this. The objective of this was to demonstrate how quickly we could actually get confirmation, how quickly the blocks would be confirmed, and how quickly each amount would change once I dispense more algos into my account. For reference, when you add more accounts to an algo wallet, your pending rewards would alter, and your total rewards would also change. So you'd see that reflected. But given that testnet is under maintenance, that isn't working. So just to show you what the code does and how simple it is. Okay. Where are we? Okay. So this was me just kind of messing around, actually. These aren't important, but this is hashlib. This is for sending transactions. Raspberry Pi seems to be missing like some kind of hashing library, so I was trying this to see if it would work to send transactions. But simple MFRC522, again, is the RFID library. And then these are our Algo SDK. This is from the Algo SDK, right? So these are, well, this is what's important for using this app. So account, mnemonic, and transaction. So very simply, I have a remote instance that I'm running here. And then I have a associated token that I would need to verify. Hard-coded address. This is all just cosmetics, slow type. Reader method. And then here. So the way it would work, if it equals, so this is the number of the, this is the associated identity of each tag. So if it's 651 here, 651, et cetera, it'll print the pending rewards format, and I would pass in the address, the client account, and I would get the pending rewards. And I'll get the pending rewards. The same thing applies for here, except it's the amount, and the same thing applies for my last tag, and in that case, it's the total rewards. So really, it's just these couple lines of code that would be relevant for the Algo SDK using Python. It's very, 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 very simple. But yeah, so ultimately what I want to do with this is be able to send transactions on some kind of moving device. So I'll get to in a second. On a moving device. So what I wanted to do was to put this on like a train, on a small train in the back of it, have the RFID reader on the bottom of the train, tags along the tracks, and every time it would go over, it would scan the location of the track, and then send that to the blockchain, letting it know that it's actually been at that location. So that's the objective with this project. Right now, it simply reads transactions from the blockchain once you interact with it and send algos to it. But sending transactions is the next step. So I'll be updating the GitHub as well.
Does every account have these three fields? Pending rewards, mountain rewards?
Does every account? Yeah, every account has that. Those aren't the only fields, but those are the ones that I wanted to show. Yeah. Why? What's your question?
I wonder what it is. Like, what does it mean?
Pending rewards. So if you have an algo token, you're always participating in consensus. So if you have that, then these would be your pending rewards based on what's happened on the network, and these are your total rewards based on what you've already participated in the network. Yeah, sorry, it's all explained in the dev docs. For sake of time, I didn't want to go through every single one. But yeah, that's what that means.
How are you participating in the consensus if you're not running a node?
So what you do is you send a participating transaction. So you send a transaction to the network, and because of the VRF, you have to specify a certain amount of intervals. So you would say, okay, I'm participating from block 1 to block 100 in that round, and here's a transaction proving it. And in that round, anything that happens, if I am selected, then I will be given rewards. So if you specify that you are actually participating in consensus for a certain amount of intervals, and you, let's say, move your account, then you'll be considered malicious. Is that? Well, let's say you move your tokens. Move your tokens. So then you're not the holder anymore, and then you're basically not valid for that interval.
So what I mean is computation.
Uh-huh.
How you're participating. Like, what are you actually providing to the network if you're not running a node? Computation.
Nothing. Yeah, it's based on proof of stake. It's a pure proof of stake model.
Right, but it's proof of stake, but
I'm sorry? You would propose a block, but not in the traditional way. So not like in Bitcoin or in Ethereum. You're simply proving that you have your staked amount available. Does that make sense?
right, but generally the stake is like it's like put up so that you do something, and that's something that you do. If you're malicious, you lose your stake.
Yeah. So
You're not doing anything.
there's no slashing. There's no penalty in this case. For our game theory mechanism, slashing didn't really make much sense apparently. So the mathematical model in this case would allow you to participate in consensus if you set up your intervals, right? And that itself should maintain like accurate blockchain credibility or integrity.
Sorry, could you explain one more time what your consensus protocol is then actually testing or verifying?
Yeah.
I don't get it.
It doesn't seem like there's any actual logic happening.
What do you mean? Like
the consensus, usually there's some kind of thing that you verify that the block is progressing properly. Nobody's doing anything malicious, but if you just stake and then do nothing, someone could just do something malicious and you wouldn't stop it.
Well, also already what would be a malicious attack?
Yeah,
Because
that's
if it's not the case like with Bitcoin, then, or with the train, so perhaps nobody's really interested to say the train, well, now you turn right because, I mean, it's
It doesn't-
people into Frankfurt, so.
it doesn't really make sense to attack this network because the trade-off or the reward wouldn't really make sense. Like it wouldn't really allow you to benefit anything.
How would you even attack it though? Like what does an attack look like?
Well, an attack in this case would be, let's say, if everyone sent transactions to the network saying that all these tokens are available for this amount of intervals and they're not, then that would be a malicious attack. But even then, there wouldn't be a corresponding reward that would make sense for an attacker to even leverage that or take advantage of it.
Who decides on the order of transactions?
On the order?
Yeah.
Well, the block proposer and the subsequent committee that would come after it.
And who proposes the block?
Anyone. Any token.
Yes, about
So you-
the proposal, you said it's randomly. How does random works to become a block proposal?
How does randomness work?
Yes, like you said, it's a kind of lottery
Right.
to become a block proposer.
That's what the verifiable random functions do. I can pull that back up. Well, that's what the VRF is. It's a derivative of ZK snarks. There's randomness inherent in that. The underlying mathematics I can't explain to you, but to be honest, yeah.
How are stakers incentivized? How are the stakers in the system incentivized?
Through rewards. So
Yeah, does it depend on the amount of the stake?
yes, it does. Yeah, it does. So the more stake you have, or the more coins you have in the network, the more likely you are to be selected. Yeah.
Did you already land in the QA section, or is your
Yeah, no, we're already in the QAs. The talk is done, but I was doing QAs. Yeah.
Because then you could throw the black box. You see this, the cube?
The what?
Left next to you.
Oh, two people.
You notice this is on, so people can talk into it.
Oh, that would have been helpful.
So if someone else has a question, you're free to speak into the cube.
Through it. Okay. You still look confused. But we can talk after, so I can explain it better. Okay. I think I'll end it here then. All right. Thank you.
thank you.
Like consensus is not.
I'll move all this.
Yeah, no rush, no rush. And is this like an ear?
I just wore it, yeah. It's
I've had one of these before.
I never read it.
So you're going to cool down a little bit and we bring in more seats, yeah? Okay, we have some? Okay, then 5, 7 minutes back here.
Cool. Hopefully this is right. I'm being a bit like silly with it. I can't seem to. I don't know if my head's too big.
So I think it's like right now, and I totally understand why as well, and because they give an attribute, a feature to the blockchain, which is necessary.
Like if you're doing smart contracts off chain, you're basically publishing what you see. Like
Cool. Thank you. Cheers. Fingers crossed.
So it's basically, yeah. But then you have it multiple times off chain, because then again it's a little bit like the consensus. How do you verify that nobody is tempting with the code off chain?
No, I mean, you get to have smart contracts. It's just, I think for scalability reasons, we didn't start with it.
Okay. I mean, it's,
I'm still confused about fetishization smart contracts.
I don't get the on-chain. I don't get the on-chain.
I mean, it's
necessity.
simply an else statement that everyone else agrees on. It's not
Yeah.
anything like inherently. So I never understood why it's so valued. I mean, I understand what people were wanting. It's simple enough. It's in theory.
We don't have smart contracts either. Actually, we're using transactions as well.
Yeah.
Yeah.
well, I think it's just this way of putting, like, to have like one business logic, let's put it like this, in one contract, and then you have another one and another one, because with transactions, yeah, for sure you can also do that, but out of a mindset, I want to have this governmental rules implemented, implemented and stored on the blockchain, and somehow fits in the mindset to have like this one contract lying there.
But even then, you can have the rules in a decentralized place, right? Like you can have the rules published in a place where nobody else can tamper with it, and where they're readable to everybody and checkable to everybody, without necessarily having the logic happen on chain.
Yeah, I'm just saying that out of the, I think this decentralized character and to store everything, I mean now we're moving since like last year perhaps, a little bit 1.5 years, we're moving more to off-chain again,
Yeah.
being like, okay, it makes no sense to put everything on-chain, but it was the first movement
Yeah.
to put it there.
Yeah.
So now we are older and we are wiser and so on, so now we move a little bit back and say old good times. But I think it's just this movement, so everybody now is has this attitude of asking for smart contracts, or if there is a functionality to somehow represent it also off-chain, because even if you want to do it off-chain, then as I just said earlier, you somehow have to make sure that off-chain is not tampered with.
Yeah.
I also think it's a unifying factor as well. Like being a Solidity developer, the developers I think is like a, I mean it creates more value. Yeah.
I don't want to use it. I did it once and it was enough.
But I've never written in a language that
Nothing worked. Everything you do normally with code, it's just like, no, we don't have this function yet implemented. No, you can't do that. No.
They're good?
Yeah, yeah. Is this okay actually? Like, is it?
Sounds good.
Does it sound alright? Okay,
Yeah,
cool.
it's not so much for the people in the room, but for the people that we're
Cool,
recording.
cool, cool.
Then it will just help. Let's see.
Cool.
I know that it's too hot for this machine, right? So it's the gigahertz is going down. And actually, this camera is supposed to show you.
Oh really?
This string is not but I think
Unusually hot. Unusually hot.
Okay, now we got lots of climate.
But it was so complicated because all the basic functions and variables you normally use, they didn't work. And really there you could feel that the original idea, was really to do numerical transactions and without storing anything else, without having anything else. This was at least my impression.
Nice having a demo with the Raspberry Pi. That was, yeah. It's cool to.
They did that same demo 2 days ago, so that's nice stuff.
It's the curse of the tech demo, isn't it? Yeah. Yeah.
Even then, it wasn't working like half an hour around the man.
I think sometimes also like when you check and then you check and then like somehow in the checking sometimes one tiny little thing goes off as well. Yeah. Yes. Yeah. I'm with Liz.
But then again, it's not even so much anonymous because somehow I have to. I have to break it. Well, yours is a little bit more than mine because in my case it was really you need to know that person to actually break that person to create a connection.
Okay.
So it basically was decentralization also.
Thank you.
And that you can demand money of a person you actually don't know, but like LinkedIn, 5 connections over. No.
Are you guys more fan of proof of stake or proof of work?
Which type of proof of stake? They're different ones.
Like as a developer, I mean, as
Proof of work.
economically, like proof of work.
Yeah, proof of work.
Yeah, I think proof of stake in the long run just doesn't hold up well. You know, like it just needs some concentration.
And you also have too many points. Yeah, if you have too many points, also I find with proof of stake you have to keep track of and you have to keep in mind.
Yes.
Yeah.
They're more expensive.
Exactly.
Oh, yeah, but it depends because there are different ones. Like for example, there are also some examples. Yeah, and then you have a timer and whatsoever. I mean, there are approaches, but it's still you have like some vulnerabilities which you don't have. Like an old mentor of mine once said, always choose the most simple formula, and that's proof of work. It's the simplest one.
Okay, so we're at Humboldt University. Yeah. Yeah. Cool. And there's a link to that on our website as well, so you can go to like list events. Yeah, cool. That's a good shout.
So it actually uses the memory bottleneck as a constraint.
Or it's called memory hardness.
What's the stupid question? Nothing stupid. Thank you
Oh,
very much.
okay, that's right.
Hash graph. What type of thing does that use?
They have a DAG.
Just okay?
Yeah, no, it should be good. Yep. All good. Thank you. Thank you, Stefan. Bring him back in. It's good that you had such a high turnout, like almost unheard of at meetups, right? Yeah. Yes.
Okay, then we can start with talk number 2 by Rachel from this.
So, hi.
We brought in lots of ACs and we closed the windows. Please get it too hot. No one, just shut up and say, it's getting too hot. I'll bring water, okay? Thank you.
Cool. No, thank you, Stefan. It's great to be here at Coding Berlin, particularly at the end of a super busy blockchain week and see like so many people here. I think it's almost unheard of for a meetup to turn up with like full capacity. So that's awesome. My name is Rachel. I'm a tech evangelist at Lisk. It's a slightly corporate slide we'll show. I'm also here with Monica, who's our events manager. Before I start, I'm just curious. Put your hands up if you've heard of Lisk. Nice, cool. Keep your hands up if you feel you're kind of pretty knowledgeable about it in Lisk. Okay, okay, cool. So that's nice. Today we've got quite a lot of you who've already heard of us, but I can give you a little bit more info in terms of where we're at, what we're building, and give you a kind of deep dive into our SDK, and you'll have a little look around at what the developer experience for that is and what's going on there. So first of all, I think it's always good to start with the vision. What are we doing here at Lisk? We are building the tools to enable developers to build blockchains using JavaScript. We've always been a JavaScript project. As we know, JavaScript's the most widely used language and it's ubiquitous for the web. So we think actually it's a great window to make blockchain more accessible to wider developers and kind of get a more mainstream audience. They can start building and then hopefully we can start getting more mainstream users through developers who are building JavaScript and making it accessible. But let's drill down into the overview in a little bit more detail. As I said, we're building an accessible blockchain platform. I'm going to show you some of the developer experience and you'll see how actually it's quite familiar to some development you may already be familiar with. So hopefully making developer experience slightly less painful than it could be. We are a delegated proof of stake consensus mechanism. Now we've already had quite a bit of conversation around consensus mechanisms, but it's one of the nice things, I suppose, both about delegated proof of stake and proof of stake is that they are all much less environmentally impactful than proof of work. So it's nice that we have a kind of more eco-friendly blockchain. We have over 50 employees based here in Berlin. And with those employees, we're able to have a lot of commits to GitHub. All of our stuff is open source from our SDK, from our core node code, and to all of our wallets. So you can go there and take a look at everything that we do. And we've got, we're always consistently rated one of the highest, one of the most contributed projects in the space. So I think Crypto Miso gave us 4th, which is pretty cool considering how many projects there are here. We have community centers in Utrecht in the Netherlands, also in Tokyo and in China. This is something quite nice, but it's actually come out of delegated proof of stake. We have delegates and block producers who are really committed to the project and really want to help grow the ecosystem. And they've set up completely independently of us here at the kind of Lisk HQ, own kind of centers which are co-working spaces, they have incubators, and they're running meetups, all sorts of things. So definitely recommend if you're in Holland, go and check out the Lisk Center Utrecht because it's a great place for not just Lisk, but generally blockchain overall. So it's pretty awesome there. Our mainnet's been operational since 2016, so almost a little bit of a dinosaur in the space. And through running and maintaining that, we've gained like a lot of experience. A lot of change has come there's been a lot of change on mainnet during that period, and we can actually pass that on to any developers who want to build with us using our SDK. So this comes on to our Alpha SDK. We launched this just over a month ago, and it was a huge milestone for us. It's really what we've been working towards, to get something in the hands of developers that they can start playing around with, they can start building proof of concepts, they can start learning how to work with Lisk. I've got this slide because it just helps you understand how Lisk main chain and the SDK kind of play together. So over here on the right, we've got a little diagram that's representing the mainnet. We've got 4 nodes there. Of course, we've got a lot more. We've got 101 delegates, I think over 200 nodes on the network itself. But we can see that each node is made up of, we use Lisk framework, which is, as the name suggests, the framework. And we can supplement that with extra functionality from Lisk elements, which is our library of like JavaScript functionality, everything from cryptography, sending transactions. It's all up there, and it's on NPM for us to use, but also you to use, whether it's in your blockchain applications or even in your clients, in the clients as well. Of course, the nice thing with JavaScript is we do have a lot more flexibility to kind of write code for Node.js, but also write browser code as well. And all of this is running on Node.js. Over here, we've got your application. So this could be something that you could build using our SDK. And you'll notice that it's using the same, we're giving you exactly the same tools that we use to build the nodes on our mainnet. You'll notice, though, that they're not connected. And Lisk, we're not building a single chain network, we're building a sidechain ecosystem. So the idea is that Lisk will become the native or universal token of this ecosystem. Right now, we have a science team who are really investigating the topic of interoperability. As you know, it's a very meaty one, and devising the best strategy for that. But we wanted to get our SDK out in the hands of developers ahead of that, because actually there's a lot of learning that we can do from how people use it, and also our community members can have more time to learn how to work with Lisk, and we can build the features that they need and grow together. And then when we have our production SDK, we'll be bringing in that interoperability piece. So right now it's proof of concepts that you can start building, but getting familiar with our SDK there. So what can you do with our Alpha SDK? You can bootstrap your own blockchain. It's really easy to do, and it's using tools that are very familiar to you. So I'll show you the dependencies in a minute. It's very easy to kind of get just like a single node running on a laptop. You can do that just in a matter of minutes. Of course, you can kind of build on from that and deploy out and build your own networks, but it's excellent for prototyping and kind of rapid development. Defining custom transactions. It's quite nice actually to hear that Algorand are also using a transaction approach, and we found that for a lot of use cases, actually having a smart contract language is not always necessary, and you can actually create a lot of bespoke business logic using custom transactions. It's like if you wanted to build a decentralized social media site, you might have a transaction for creating a post that could contain all the data for that. You could have another transaction for liking a post or commenting. I'm going to show you an example of that in a minute, actually. There we go. As well as defining your custom transactions, which is where the business logic will lie, you can also configure a load of attributes. So we're kicking off the configurable attributes with block time. So Lisk ships with a 10-second block time. You could decide that you'd want a less frequent block time if you wanted to hold more data in those blocks, or maybe have a more frequent block time. That's configurable. Block rewards, you want to be more or less generous, and block size. And we're going to be adding to that as well. I think we've got epoch time as well, so the kind of staggered points that you could change the block rewards, and you might want to give a higher block reward at the beginning and taper that down. As I said, at Lisk, we're all about accessibility, and that was the reason why we chose Node.js as the kind of language for the ecosystem. These are the dependencies that you need to install. So Node, if you're a Node developer, you're obviously already using that. Postgres, it's a database that's very common in web development. And we also have Redis optionally for caching. Again, very familiar tool to a lot of web developers there. Once you have that installed, and I'm going to give you a little walk through how you could create a custom transaction so you have an understanding of that. First thing you'd want to do is just use npm to install our SDK. And then you can create an index.js file, pull in application, the Genesis block, and config. And then using that, you can create a new instance of an application. And then it's just a case of calling the run method. And we've added some very basic logging and error handling here. Once you have that, you just need to make sure that you've got your database running and you've got your Lisk user set up on that. And then you'd be able to hop over into your terminal and use Node and Bunyan, and you could run the local blockchain like that. And you can see it's setting up loads of stuff for us. It's processing, it's creating all of the delegate accounts, so generating the public-private key for them, and we can see at the bottom the blocks are coming through just on the 10-second default block time. This is obviously a GIF, so it's just looping back around. It would keep adding blocks in reality. Cool. So that's how you'd get just a very simple blockchain running locally. As you can see, it's very minimal code, and the Node developers amongst us will say, hey, that looks very familiar to like Express.js. That's been very intentional to kind of give us a kind of familiar developer experience. If we wanted to change one of the configurables, in this example, we're switching to a 5-second block time. It's just a case of passing in a config object. And then we could go over to this Lisk Explorer, which is our block explorer that we use for the network and testnet. And you could configure it for a local devnet. And in this example, you could see that the timestamp has changed to a 5-second increment there. So I'm just going to talk you through custom transactions because they are very important to our network and how you work with our SDK. So we have this cashback example, and I'm sure all of you have credit cards and whatever kind of familiar with this. It's the idea that you send a transaction and you get a little bit of a bonus back in an inflationary way. This is a super generous one. It's 50%. So like if these guys make a credit card, like definitely take one with them. But yeah, Alice is going to send 10 tokens to Bob and get a bonus like 5 through the network. Importantly, it's not coming from Bob, it's coming from the network. Cool, so how could we write this? First of all, we would create a file for this custom transaction. And in this case, because a cashback transaction is actually very similar to a transfer transaction, we can actually just extend that. We don't need to actually rewrite all the logic again. We don't need to reinvent the wheel if we don't need to. So we're pulling in the transfer transaction, and here we're just going to extend it to create our cashback transaction. This is nice because it means that all of the logic of removing the 10 from my account and then adding it onto the recipient's account is already handled for me, and I only just need to write this bit of extra logic, which is around the 50% bonus. So we can see here we've got this apply asset method, and here we're calling super on the store. The store is basically our wrapper for the database, so once you do that, you can actually access things like sender's account and update the account detail here. And then we've got our business logic, just updating the sender's balance, and of course we're using big number to kind of handle those numbers securely, and update the sender, use the store to finally also update the balance afterwards, to append that to the account. After we've done that, we just need to write a undo asset method, which is pretty much the same as apply, but you'll notice that it's actually got a subtract rather than an addition, and it's just doing the inverse. And that's just because if something happens when it's in the transaction pool before it's reached the blockchain, we need a way to reverse the logic. So it should always be the inverse. And then we export it, and then we hop over back into our index.js file, and once we pull it in, we can just use the app.register to pull in our transaction type into the blockchain. And again, looking very similar to how we might work with middleware in Express. So we have this little diagram. So here you can see there's an account that had 100 million tokens. This is not actual list because it would be the tokens native to your SDK, your chain. And then made a transaction of 1 million. We'd expect in the end the balance to just be 99 million. We can actually see it's 99.5. So it's got that 500,000 kind of cashback bonus there. Cool. So that's just a very simple illustrative example of how you might work with custom transactions, particularly interesting for people who are maybe used to working with smart contracts and curious about how a transaction might work. We built this proof of concept called list bills. When we were launching our SDK, we thought, let's have a little bit of fun, let's come up with something that we can kind of use to demo the SDK. And we came up with the concept of invoices, and we've all probably had to partake in some sort of invoice exchange, whether we're sending one or chasing one or trying to get our invoice paid. Use case, you can create an invoice, you can receive an invoice, and you can pay it. What did we do? We did a lot of brainstorming. We worked out like what the user journey would be, what fields our transactions would need, and how we'd handle it. Then we did some coding, and this is the tech stack that we built our proof of concept using. So obviously with the main chain, with the SDK, what was working with Node.js and Postgres, and we've just got a local instance running there. And then we built a front end, just a simple front end using Create React app. We've got the key storage there, and we're able just to use HTTP to communicate to the blockchain running locally. And now I'm going to just do a little quick demo of it on my laptop so you can see. If you are interested, as I say, everything we do is always on GitHub, so you can actually go to this URL and you can check out the code and kind of have a little root around or like run it locally. So let's dip into the demo. So here I have my blockchain directory, and just using Node to run that, I'm just going to pipe it into Banyan just to give us some logs. And we should see, again, it's just setting things up and the blocks are coming through. Should be another one in a minute. There we go. Now, if I go into the client folder, I can just start this with npm start. And then I'll go over into this one, localhost 3000. Cool. So here we have the interface. I'm just going to log in. Obviously, these are just dummy accounts. So here we go. And now I'll log in incognito on the other one. Cool. So we have these two accounts that are logged in. Now I'm going to use this account to create an invoice. Send a new invoice, and let's send it to this address here. Amount for cat sitting, maybe. Cool. And now we have that. Now when I press send, it's just going to create the transaction, and it will use HTTP to send it to the local blockchain running. And then if we go back over to this one, we should see it pop up any minute now. Fingers crossed. There we go. Cool. It is a 10-second blockchain in this demo, so it does take a little bit of time. Then I can actually just go over to this, and I can say, cool, I'm actually just going to pay that. And then it will go back, and in another 10 seconds, that will change to toggle to the pay status. And we know I've actually received the invoice, and I've sent the payment back. Cool. There we go. So that is just a little demo. Yeah, so that's a demo. As I say, this is our kind of first SDK launch, so we're actually really excited to see what the community is going to start building with it. We've already got some people who are building a demo of a Lisk bike, which is pretty awesome, so you can kind of lock it and pay using tokens. Pretty cool. But if you are interested in kind of building accessible blockchains and playing with our SDK, please join us. Tomorrow we're going to have a hands-on workshop, so anyone who's a JavaScript developer or familiar with Node, or even if you're not, come along, you can scan that and join us. We also have another event on Thursday where one of our research scientists is going to be digging into our consensus mechanisms in a little bit more detail, so that's actually a really good event if you want to kind of explore some of that, and that's at Humboldt University on Thursday. All of these events are also on our webpage. This is like lisk.io/events, or find the events tab on our page. But yeah, it'd be awesome to see some of you tomorrow, and it'd be great to kind of like do a few hack demos and start building our own custom transactions. Cool. So thank you for listening, and thank you for having us. So, do a couple of questions. Oh, sorry. No. Sorry.
Hello. When you have this side chain, you always need Lisk to pay for transactions on the main chain, or how does that work?
So on the main chain, any transaction on the main chain will be Lisk, but on a side chain, it will be your own native token. So you'll create your own token on your side chain.
But the main chain validators, they also secure your side chain.
No, you would have your own validators on your chain as well. So you'd roll it out you build up your own network of nodes and validators.
So the main chain just allows me to transfer balances or value over to other side chains, basically.
Yes. But there's going to be more information about interoperability coming later. I can't answer it too much because it's still in development right now.
Thank you.
Hello? Yeah. So during development now, the SDK was running on a node server, right?
Yes.
Okay, so on release it would be on the mainnet, right?
No. So with the mainnet, you can't actually deploy custom transactions. The mainnet has a set number of transactions which are mainly around sending lists. So if you've ever sent lists, that's where it's happened. You can also have transactions around registering delegates. Your business logic will be on a separate chain, and then you can create your custom transactions there, but you won't be able to send that into main chain, if you see what I mean. The only thing that the only thing that will be interoperable will be the list token, which can come into your side chain. But as I said, that's in development, so I can't answer too many questions on that today.
Okay.
Sorry.
No, that's all right.
But please, you might be able to ask Jan some more about that, because he's actively researching this at the moment, if you come to the event on Thursday.
All right, perfect.
So what are your primary uses for the main chain, or use cases?
So we see the main chain as being like the kind of native token that you could exchange for other tokens on sidechain. So it's like the kind of, as though we had this analogy with our white paper, which was like probably a bit out of date since it was 2016, but this idea of it being like the App Store, and this is the kind of token that you could get hold of and use to transact for other tokens on other DApps, like would flow throughout the ecosystem, so to speak.
But so would it not be possible then for sidechains to transact directly?
I think it would have to be via Lisk, but I think that will be something that will come out more when we release our interoperability research. Right now, I unfortunately I can't say, sorry. Cool. Awesome, thank you.
Thank you.
Cheers, thank you.
Hot enough?
It's really hard, yeah.
Okay, do you need another 5 minutes break maybe? I mean, it's always bad going out, going in, right? It depends on you people. What? You don't need to? No, you want to talk, right? Okay, you're fine with just staying here and we hear the third talk? Yeah. Okay, then let's do it. Where's our speaker? Yep. Yeah, you have to. We got 2 parts for it, right?
I know, right?
Yeah, there you go.
Thank you. Cheers.
Thank you so much. It depends on you if you're prepared. If you feel
Maybe just.
So as long as he's mounting himself, you can ask questions. Questions. And if someone needs another beer, you know where the fridge is, right? You need water?
Yeah.
I'll bring you water. This is HDMI. If you need HDMI, no, this is USB-C. No, this is not good. You only have to drag. No, this is an old MacBook, right?
Older MacBook? Yeah. Maybe this fits. Gibt MacBooks so richtig HD?
I think you have to do this in English.
So we'll just like
Because we have to take care of the barbecue.
yeah, right. So that they know roughly when to be ready.
That's still on, right? Take your time. It's okay. Currently, everyone sees what you're seeing.
Because it's like on
You go to see over there. I can type it for you. I can type it. I'm as a German, this is. So there's a slight chance that this TV set is shutting itself off in 1 minute. I will have to put it back on. So if you don't mind, wear the microphone, because we're doing stuff. So I'm not putting anything on it before asking you. But if you put it on, we have the sound on. That way, shutting off our laser trucks. Nobody don't notice how to put it on.
make groups of
Now the speaker is gone, but I managed to load the presentation. You know what PowerPoint karaoke is? You know PowerPoint karaoke? No? It's like you get a slide deck and you don't know what you get and you have to present it.
Oh, wow.
Ah, it's really good. The speaker passes out, so you have to play it. Anybody still remember the discount codes of the React Days Online? Who's going to the diffusion hackathon? Who wants to join my team? Marketing. I have to be involved, obviously. So sorry, I just wanted to reload, so I reloaded and then I touched some button and now I.
Okay.
So I did not steal the passwords. If I did, anybody.
No, we are going to open this shortly. So, it's our NDA.
Sorry, I crushed your.
No NDA is being signed. Wait, what?
This one on, put it in the pocket, turn on the camera.
Hello, hello, hello. Yeah, works.
So, Dimitri will talk about Helix AI, yes? About this very nice type of temporal messaging and hybrid network stacks. Whatever that means, I am very excited.
So thank you for such a warm welcoming. So I'm Dmitry, I'm Chief Scientist at Helix. So first of all, subscribe to our Telegram channel, like Twitter as well. So today I'm going to talk about tamper-proof messaging, whatever it is, and hybrid Web3 stacks. So I'm going to be like a bit more general in comparison to the previous talk, but also more like kind of use case oriented. So we start with the basics, like with Satoshi. So if you remember that Satoshi Nakamoto never actually used the B word, like the blockchain word in the Bitcoin white paper. It was actually introduced later on, and what he actually called this thing a timestamp server. So he explicitly writes there, so the solution for the electronic cash begins with a timestamping server. And this is actually the initial point to depart from. And our goal was to actually reconsider the design itself rather than trying to, for example, build another Ethereum killer with a million TPS, but rather like to be sort of contrarian here and understand what we can actually derive from the original idea. So why actually it is called a timestamp server? Because the Bitcoin network uses this hash clock based on the proof of work and the difficulty levels in order to achieve a global ordering of the transaction log. And thus, once you have a global ordering everyone agrees on, you can prevent double spending of BTCs. So from the distributed systems point of view, Bitcoin is AP, like in like CAP, like cap theorem, it's actually AP system. So it is available, which means that you can always submit a transaction to a full node. It is partition tolerant, so even if the network is partitioned, it continues to function, but only eventually consistent, which means that if you if the network heals after the partition, then there is a reconciliation process, and there is this famous rule which actually tells you how to reconcile. Actually, it is as simple as choosing the longest hash, the longest difficulty level, and this is why it is eventually consistent. And then, due to the game theory there, and like one CPU, one vote mechanics, it is not very hard to show that as long as you have many confirmations, the probability that you will change your local view after the reconciliation drops exponentially. So you actually have a very secure system here. So on the other hand, in many situations, we don't really care that much about money, and Bitcoin and all the successors, like all these B words, were really inherently about cash transfers. So it was never about data payloads and like what is called zero-value transactions. It was always optimized and designed to facilitate peer-to-peer payments, so that you can very secure and censorship-resistant way give some Bitcoin to your friend, right? And putting data into Bitcoin was sort of a non sequitur later on, because people understood that, okay, this is a highly available system, it is highly replicated, then that it is safe, but there is so big overheads that actually it's pretty much impractical. But so this was like the starting point. And we decided that, okay, we want to start with the these premises, so we want to have a highly available system, so that we actually more about data, so that you can actually send mostly data transactions, and we are partition tolerant, available, and also eventually consistent, but and the reconciliation process is powered by the Helix mesh consensus. So when I say like a messaging broker, like literally messaging broker, it means that everyone in the system can submit a transaction, which is typically just a data payload, and the receiver will, so this message goes through the Helix network, and everyone in the network will see that this message has been sent at that particular time and that it has been delivered, even if the recipient is offline. So how does it compare to the blockchains? So actually, in order like to optimize for throughput and the data, we ditched the whole idea of having global ordering of transactions, but rather the only thing that matters here is the timestamp here. And the timestamping here is powered not by proof of work, but by the assumption that most of the nodes have synchronized clocks with UTC. Synchronized, I mean approximately sync, because you never can have ideal synchronization, but it is fairly safe to assume that they're like within 1 second. So if we have what we call round, and basically the consensus here is that a set of transactions without any particular ordering within the set is achieved, it means that all, for example, transactions in this block were submitted no later than this time, because the majority of the network have seen these transactions before this time. And we have like a discrete intervals where the network timestamps the delivery of these messages and acts as a broker. So this seems like a very simplistic thing comparing to all the smart contracts and all the modern blockchain with interoperability and like with the whole idea that you want to put all your processes on the blockchain and trying to automate this. But the point is that according to our talks with like our industry partners and like lots of research in the space, it is fairly clear that B2B use cases are genuinely different from the cash and DeFi. Because here, like, what are the main points of having like very secure smart contracts for cash and DeFi? Because what you want here is like to be censorship resistant. You want to be anonymous, so the full nodes are anonymous, and you cannot track any transaction. It is also autonomous, which actually means that whenever we send a transaction, it is automatically executed without any actors being involved. It, as a consequence, leads to only use cases were really closed within the ecosystem, which means that, for example, on-chain rewards and economic incentives to run the node must actually accept the native coin as the reward and on-chain reward mechanics, because you cannot actually assume that there is anything outside of the system. And if you go as far as like to introduce sharding and scaling, then data availability becomes a very hard problem, because if you do not have all your state on a single node, you have to somehow be sure that someone else in the network has the rest of the state and all the data. And as long as everything is anonymous and like completely trustless, it is actually quite hard, and you always should rely on some like soft things like economic incentives, like slashing, and this is actually a very hard thing to do. But for B2B use cases, the whole setting is actually quite different. So what is like a real pain point there? It's not actually about being censorship resistant, because once you're like a big enterprise and a vendor, typically you always have access to internal database. It's just like not the case that you kind of afraid that your AWS operator or like your ISP provider for some reason will block your business transactions because you're not like dealing on the Silk Road. It's not actually that case. But what is valued here is that you're accessible and highly available, meaning that you can access this network even within different data silos in the different regions. It is auditable, so you can actually show your audit trails and all your data to the regulators and to your business partners. You can assume that the vendors who actually typically will run the full node are mostly trustworthy. Mostly, I mean, in the sense that, for example, if you have like set up like a local mesh network, when you have, for example, 2 or 3 vendors, this would typically be enough in order to conclude that 2 of these vendors are not malicious and one may be actually acting in an adversarial way. And also the adversarial way here is typically not like mindling with the code, but rather like being unavailable. So it is a very hard to imagine situation when a vendor who actually has this soft reputation on stake, because this is actually their business, will try to meddle with the system. Another point here is that even if there are some problems with that, since the vendors and the node operators are not really anonymous, if you have all the data on-chain and like auditable, then you have a very strong leverage, and you can use off-chain and legal system in order to actually initiate the litigation process. And moreover, if you have such a system, most of the time you would actually see off-chain cash settlements between the B2B counterparties, because this is actually how their processes work. They already have their accounting system, and they will hardly change anything there. And like a punchline here is that in order to succeed with business adoption, you really need to be like an overlay layer, meaning that your protocol and blockchain solution is non-intrusive. You cannot really convince your business partner to break down the business processes that work and put them into some very experimental smart contract platform. Rather, they would try to use them both for many reasons, not only from the technical point of view, but also from the managerial point of view. So that's why our motto is just like be very slim and non-intrusive, pretty much like I am here. I'm slim and non-intrusive. So that was like a general introduction. I was originally trying to be more technical on the like an architectural point of view, because this is, I think, something that is typically overlooked, and people like silently assume that, okay, here our like wonderful blockchain platform, we put everything there and nothing exists outside of it. But this is never the case, because typically you have IPFS node, Infura, everything like centralized DBs and everything. So originally I wanted to talk about like this kind of Web3 stack, as people put in there, but instead I will just give an illustration how you can actually combine different stuff in order and how we actually do this ourselves. So here is our Helix full node, which have different components. So we have like a core here, which actually isn't here, like a full node running the ledger database and like peer-to-peer transaction processes. It exposes an API endpoint, which is used by the wallet through the SDK. And since in our setup, we assume that the vendor is trusted and never censors the transaction, this actually is quite a secure setup already, because you cannot sign a transaction on behalf of your client as long as you don't do any custody. But everything else is already in this thing. On the other hand, you have like load balancer in order to facilitate lots of transactions, and you can subscribe through ZMQ provider on the messages, because we are like a globally available messaging broker. We actually expose all our APIs through the ZMQ. And ZMQ is actually our sort of role model, because this is very simple to use, and I will not even show you any like specific SDK comments, because this is like fairly trivial, and it takes only 1 hour like to understand how you actually connect to the broker, because whatever basically all you need is just like API endpoint, and you go as we typically would do with like ZMQ thing. Also, we have this kind of weird things like relay providers and nominees here. So these relay providers are just nodes who do not accept client transactions, but rather relay transactions in the peer-to-peer network. And since we have this special relay nodes, the number of hops is always bounded, so we have actually quite fast, quite small latency. And again, in a Bitcoin or like Ethereum network, you wouldn't typically assume that you have like any sort of assumptions about the network topology. But when you're like more in the B2B case, it is fairly safe that you actually have your relay nodes in the network, and if for some reason it stopped working, you always have a gossip networking as a fallback. But typically it will work and you have very small latency here. And finally we have here like nominees and like Aragon, and this swap contract is like Helix DAO, and this is actually our fledgling government setup, and originally it is used only in order to facilitate cross-chain swaps from native coin HLX to Ethereum, so that once you submit a swap request, nominees observe this transaction in our native network and approve it through the Helix DAO process, so that the coins are minted in Ethereum. And this kind of wonderful composability allows us first to upgrade the contracts when necessary, and also experiment quite a lot, because our Helix Network 1.0, which we launched at the end of September, is more like an MVP, because it's actually proof of authority, and yeah. Yeah, here it is.
Should I stand here?
Yeah. Yeah, so we have a proof of authority network, so all the key components from the Helix Test Consensus protocol are in there, but we can manually experiment and tune many things without actually going astray. Yeah, so the moral from this picture is that as a integrator and a blockchain engineer, you always should think about the whole ecosystem rather than trying to focus and put all your sort of mind share in a single dApp or a platform. Okay, so now we come to real use case, which it was actually studied by Accenture, in 2018 to 2019. And the problem is that we all know about overfishing, and tuna is consumed like crazy, and fish die out. And we want to have sure that if you want to some fancy coffee shop here in Berlin, then the tuna sandwich that we eat is actually ethically sourced, and we don't support crazy parties, whatever. So it turns out that 30% of the whole tuna in the world is caught in Indonesia, and it's not the most technical developed country, unfortunately. So the whole process from the catching boat to your favorite avocado store and tuna store is actually quite long. So we have vessels, in a port, and then we have a broker, and then it processes this, then there is a mixing of batches of the tuna, and then they go to the export. This is actually a US specific thing, and then there is paper documents and confirmed chain and custody. So it is actually quite difficult to track the whole supply chain, and mostly the challenge here is in this part, because this part is already quite automated. So how would you do this? How would you solve this chain supply problem in order to track? Actually, the key challenge, as I said, is the lack of digitalization and unreliable data at the catch site, because typically people actually take papers, write something, and then submit it. Some data is lost, some data is malfunctioning. If someone tells you that, okay, we'll put our blockchain solution there, it resolves sourceability problem, they will lie. Because I can always put my temperature sensor in the fridge at my home, and it will happily submit very nice transactions that I have 5 degrees, and blockchain will be happy about that, and but I will still having everything astray. And the same with the tuna. I can take RFID on some single fish and then catch, for example, 10 kilos of fish just off the shelf, and no one will ever detect this on the blockchain. So how would actually Helix help with this problem? Because as you see, this is not really a technical problem, but also integration and social problem here. And the key factor here is actually the amount of data. and the availability of this data. So if you have a fishing boat, and on this fishing boat you have lots of sensors such as GPS tracker, like weight tracker, RFID sensors on each fish. You cannot fool every single sensor, but as long as all these sensors submit very granular data, which is actually attested by the Helix network, you can build a very complicated data audit and analysis on this and actually detect the fraud. Because actually this kind of things can only work if you do some data science on this, and if you have just a single sensor, it's impossible. And the point is that if you just put like a hash on your data on blockchain on Ethereum, typically this data is just not granular enough, and you don't have enough data to have any meaningful conclusion. First, because it's actually off-chain, and second, it is not granular enough. So you actually have it accessible from everywhere, so the audit can be actually done from any other authority, even for example on the US. The US authority will be able to access all the data directly from the fishing boat in Indonesia, and then it will decide itself whether it is ethically sourced or not. And this is actually like a complex problems, but there is like a clear path to the solutions, because we at Helix Network work with the vendors and onboard them as partnerships, so they actually shield they do the field installation, and they shield all the crypto stuff from the end customers. So for example, the fishermen will never be exposed to the crypto stuff at all. They will just have a single mobile app and the sensors, but the vendor will facilitate the data delivery out authenticity to all the partners without even having a partnership with all the participants in the network. So this is actually like a win-win situation, and the vendors are actually our target audience to run our full nodes and integrate it. And again, as a slim and non-intrusive protocol, we do not assume that the solution itself will be built only on Helix. Typically, there will be lots of other infrastructure, possibly centralized and decentralized, but the key thing that whenever you have this data, but typically actually it will be like metadata, but on a very granular level, so that everyone can access this data and ensure that this data has been submitted at that particular time interval, up to 5 seconds. Okay, so do I have time?
25 minutes.
Okay, yeah, so yeah, okay, then I will just mention, I can go, so right now it's like all about like complex systems, but you guys are mostly developers here, and I would suggest you like just to think about how would you use a system like a message broker, which is globally available. Anyone can connect it, pretty much like sending Bitcoin transaction, and we just put a timestamp and make this data accessible to everything. I, for example, have a very simple solution which will be retail facing and already solve like many problems. For example, everyone knows about Twitter trolls, and if you just have some trader who will say, okay, I bought Bitcoin, I sold Bitcoin on top and bought it at the bottom, and typically there is no way to nail it down and say, sorry, you just like cooked up your tweet just like 5 seconds ago. Basically, what you need is facilitate PGP encryption so that people actually can easily use it from, for example, our wallet or your wallet in one click. So this message is PGP encrypted. The PGP public key should be easily available, and actually you can even imprint this PGP signature into the profile pic using some steganography things, so that even if you take a screenshot, it will be available. And so this requires no blockchain whatsoever so far, just like PGP signing, so you can authenticate this thing. But what is missing here is the time where you submitted the message, right? And this is here we come in. You just take your signed message, submit it to their network. We attested that at that particular time this message has been submitted, and you can actually prove that this was my message through the PGP, and that was submitted at that particular time. Actually, it takes, I think, like 2 days in a hackathon, and I think it will bring value pretty much immediately. But also, I'm sure that there are lots of creative ways to use a very simple things, just as simple as just timestamping in a very unpredictable way. So I encourage you to think about it and get in contact with us. So because we are open and support startups. So we really want startups to run our full node, not just like single developers. And we can help them to develop the idea into actually a small or maybe big profitable business. This is our incentivization problem. This incentivization goal. Yeah. Thank you for your attention. Yeah. By the way, don't forget to subscribe. This is my Twitter. This is Helix Twitter. This is Helix Telegram. Yeah. Yeah.
I think we still have 5 minutes for questions if you want to take some. If you have some. Does anybody?
Yeah?
You have to throw the cube. You have to throw the cube without.
All right. Yeah. Here you go.
Hello. Hello.
Yeah.
I was wondering if you could just walk through maybe kind of one more case where someone might want to use Helix, like it's kind of business to business cases.
Yeah, so as I mentioned, you can actually come up with many retail things. Another kind of interesting use case would be to integrate our Helix network with self-driving cars autopilot, so that actually it timestamps all the model states to the network, and once, for example, the network crashes, then you actually have leverage against Tesla and can sue it for $1 billion. And yeah. Because you actually have a proof that the thing was acting in a non-expected way, and you have timestamped on it. Yeah, and moreover, even today, Germany accepts blockchain record as a legal way to prove that that was at that particular time. Yeah.
Like, can you explain how this is fundamentally different from a globally available Kafka instance for?
Because in order to achieve consensus, you have to solve the Sybil. And you cannot solve the Sybil without either proof of work or proof of stake. That's why we actually need a coin here. And and globally, because otherwise you can spam your global Kafka with bots, and then you can do all the crazy stuff with that. You really need the consensus protocol in order to make it eventually consistent. Yeah?
Hi, so can you explain how is it better from a timestamping protocol on top of Bitcoin, say open timestamps?
Because it provides you much higher throughput and granularity, because we have, in a Bitcoin you have a single writer, right? Only the block producer can write in Bitcoin, but we actually are built on the DAG, and actually, to be real nerdy, it's a conflict-free data thing, so that actually everyone can write simultaneously, concurrent writes. There is no need.
I mean, if we just take the task of timestamping data, we can put a bunch of data in a Merkle tree and put the Merkle root in one Bitcoin transaction once every 10 minutes.
But how would you do that if you have, for example, 1,000 writers? How would you do that? You would actually wait for a very long time before you submit your hash into blockchain. But in our case, all the 1,000 guys will be able to write it at the same time and get it on time. That's the point.
The question of security is still kind of, it may be faster, but is it actually comparably secure to proof of work like Bitcoin?
Well, it depends on right now it is proof of authority, so this is kind of automatic. Security comes from your adversary assumptions, right? And our second iteration, so as long as we get traction with our proof of authority thing, we will make it permissionless and proof of stake based. And in our case, we will have ERC20 for speculation. And in order to stake, you have to stake this coin, and you will be able to make the collateral even in Ethereum. And typically in such systems, the bottleneck, like security threat here, is that you can move pretty fast your funds, so that like there's nothing on stake attack. But as long as you have this bridge, which is not really emitted, you can always kind of separate, because our native coin will be mostly used for native staking, while the ERC20 will be primarily used for speculation and as a collateral hedge for those who will come from the Ethereum. But again, at that point, it is really like not that important, because as long as you get traction and you see how the people use it, you will get much more insights in there, because I mean, no need to have 1 million TPS if you have only one transaction, right, in the network. Yeah.
To your question, I also want to add that when you have this Merkle tree and then you put the Merkle root timestamped in the Bitcoin blockchain, then you still have the data availability problem, because you have to share this Merkle tree somehow off-chain. And that's actually not the same use case.
Yeah, in our case, you would typically also put some employ some compression in order to not spam the network. But the point is that once you put metadata in the network, then you can, for example, put IPFS handle, so then people use it. But this is still a problem with Bitcoin if you have 1,000 writers, right? Because it will clog the network. Only a single writer can put your Merkle tree in a single round, right? But yeah, you can just like have everything on chain as long as the network. And because
how expensive is it? How expensive is it to put like 32 bytes of data there? It's like a hash rate.
Right now it's actually free, because our model doesn't assume on-chain incentivation during the bootstrap phase, because our incentivation is as follows. So during the proof of authority phase, we have deals with vendors so that we onboard them in our network, and they provide added value services and implement use cases from our industry partners. And the incentivation is actually added revenue, and then we get some share, and they acquire, in order to get this, they acquire our HLX tokens. So it's like off-chain staking, so to speak, during the proof of authority. But later on, it will depend on your stake. The more you stake on HLX, the more quota in a round you have. Yeah.
Do you have an idea of what the cost is going to be, I guess, over time? It sounds like during the bootstrap phase that's handled, but like in the long term, do you know if you're a vendor that's using your protocol, do you have an idea of what your costs are going to be going forward?
What do you exactly mean by cost? Like using...
Publishing costs.
Oh, so we have like fixed supply, and the Helix Mesh protocol would work fine as long as we have less than 1,000 writers. So as long as we have, say, like 10,000 vendors, the network will be actually quite cheap. So, and we don't actually expect that there will be much more. And right now the network usage, as I said, is completely free. And the point is that if we have 1,000 or like 10,000 vendors onboarded in the network, the value from this network is so high that they will probably cover any added value cost just by delivering to the industry partners. Because even like small integration has average check like 100K euro. So that's why they actually have a very huge lever. It's B2B business is completely different from B2C. From B2C, you chase like a very thin margin, like 1 cent. But in the B2B cases, their mechanics are completely different.
So, 5 minutes ago, I received a picture of the barbecue grill. They told me in 7 minutes, it's gonna be ready, which means we still have 1 minute left.
All right.
Thank you, Dimitri, for
Thank you for having me.
I would like to take the last 30 seconds. There are stickers outside. There are flyers outside. There are even flyers by companies outside which we not even invited. They just
Right.
and put something on it. I think Berlin Blockchain Week is still running for 2 more days. There will be some events. LISC is tomorrow.
Tomorrow and Thursday we've got an event.
Tomorrow and Thursday.
Yeah.
Oh my God. So check meetup.com. There are lots of these events. If you want to go to Diffusion and join my team, you can come to my team, but you can also compete against me. Let's use developer. I don't know. Most likely you. I wanted to say something. I forgot it actually. So Coding Berlin will return. Coding Berlin is not only about blockchain. You might already have heard so. So if you are a React developer, if you are database developer, if you like monitoring, if you ever heard about Datadog or Elasticsearch, there's a good chance that our next event is going to be about monitoring and logging and, well, yeah, taking down all the important things that systems do internally. And with that, I think we can go to the barbecue. Thank you for joining me.
Yeah. By the way, if you're interested in private access to our SDK and APIs, just DM me and we will open it shortly, but developer access welcome. Yeah.
D-I-Z-H-E-L. Cody Berlin just tweeted about it. You'll find it. And wake up in the last row.
I was like, I don't know.
Could you please speak into the microphone? No, it's okay. You can talk freely.
But I was wondering if it would be possible to like partner with Coding Berlin for an event.
Absolutely. Sure, yes. You just can approach us. You can approach Tom and me. I'm more the technical guy, as you might have noticed. So he's taking care of all the organizational stuff. What are you thinking about actually?
So I work for Factum. It's another blockchain company. We're wanting to do kind of like training workshop or something like that for our SDK. So
How's it called?
Factum.
Factor, like F-A-C-T-O-R?
T-O-N.
Factum.
Yeah.
Have I heard of it? Yeah, sure, absolutely. So just approach me. We're usually doing all these meetups. We are also, we already have done 2 hackathons, but smaller ones, like 20 people joining.
Okay.
I would love to do workshops and 3-hour things where someone's really doing something with people.
Yeah.
I love to do that because all these, I mean, this is interesting, right? You get some inspiration, you hear different things, it's okay, but you don't get really into it, yeah?
Right.
When you go home, you have a barbecue night or whatever,
Yeah.
I would love to do that. That's great.
Okay.
Just approach me. You will definitely find it. So if you go to Coding Berlin, anywhere you find it on Stardoll, I'm the guy who's writing all the emails.
Gotcha.
So just just approach me. And,
Okay.
We
Cool,
get up and do that.
Appreciate
If you need, do you have a space on your own? Or because we can also provide this
Well,
one.
we were actually thinking about full node.
Yeah.
Yeah.
They approached me, followed us 2 days ago, and I have been already. And yeah, it's absolutely great. It's a great place to be. I was Beta House has opened again,
Yeah.
the new space, and they just have sent an email where they're showing how the new the workshop place is looking like.
Yeah.
And they're quite a bit, so they're much better than the old ones. And I think they're also giving them free if you do this communities. Maybe there's a good chance.
Yeah, possibly. I think we were looking at full node just because they already have like the blockchain community and all that and stuff like that. So, but yeah, I actually work at Beta House when I.
Oh, okay.
when I
So we know.
so,
Okay.
yeah.
Then do you know Julocom? Joachim Wilkamp and his company Julocom, they're doing self-sovereign identity. They're quite good in the business, I would say. So there's something very similar to Uport or Civic, I don't know, at least identity.
I know Civic, yeah.
Yeah, right. You know Civic, great, but most of the others know Uport, quite fun. So.
Okay.
And there's Julocom, which is obviously a German company, but they're doing exactly the same thing, putting VIDs on the ledger and giving you some kind of smart wallet where you can prove that you're above 18 or something.
Right.
And they're also sitting in there. Well, whatever. Just
Yeah, no, I actually sit across from the guy. That's why.
you know that. Okay, good. Just approach me.